Namaste. In today's class, we are going to take a look at Bohr's model of an atom, the distribution of electrons, and finally, we are going to close the class with the discovery of neutrons. Before we start lecture number 3, let's take a quick look at what we did in the previous class. And those of you who could not attend the class before, please look at the description below. The link is provided in the description below. Namaste. This is Shree from Eduland Foundation. In the previous class, we did a detailed study of how Goldstein discovered the protons. He also observed that protons were very heavy, and this experiment was called as the anal ray experiment. So when the protons and the electrons were discovered, it was J.J. Thomson who gave us the model of an atom, and his model of an atom is very popularly known as peas pudding model of an atom. However, Rutherford was not very happy with J.J. Thomson's model of an atom. In the previous class, we have done a detailed study of Rutherford's model of an atom, how Rutherford observed that the atom did not have positive charge particles present everywhere, but positive charge particles were present only in the center of the atom, and this led to the famous discovery, and it was Rutherford who discovered that there was a nucleus in an atom, and inside the nucleus were the subatomic particles like the protons and neutrons. We also went forward with our lecture discovering Rutherford's model of an atom, how he proposed his model, and also the drawbacks of Rutherford's model of an atom. I repeat, for those of you who were not with me, please go back to the description box for the link on this. All right, now let's get started with lecture number 3. Rutherford said atom had nucleus, and the nucleus had protons and neutrons around which the electrons were revolving. As they were revolving around the atom, they lost energy, they collapsed, and they were not stable. But we have seen that most of our atoms are stable. All our atoms are stable. So Bohr came up with another model of an atom, and let's look at what he had to explain. Just like Rutherford, Bohr also stated that atom had a positive center where the protons and neutrons were, and around the positive center, around the nucleus, the electrons revolved. But he said that the electrons were arranged around the atom in discrete cells, that is in special cells, and their energy levels were different. So what did Bohr propose? Bohr's model of an atom looked something like the figure what is presented to you. So there was a positive center, the protons were in the center, and the electrons revolved around the protons in separate shells which had different energy levels. You can assume this to be something similar to our solar system, where sun is in the center and all the other planets revolve around the sun without collapsing. So Bohr proposed that the atom had a nucleus in which protons and neutrons were present. Around the nucleus, the electrons moved in discrete energy shells. They moved in separate energy shells, and the energy shells were arranged in increasing energy level. The energy shells were arranged in increasing energy shells. He named these orbitals as K, L, M, N. He also called them as 1, 2, 3 and 4. So let's look at it again. So according to Bohr's model, atom had a positive center around which the electrons were moving in different energy shells. This is something similar to our solar system. Now let's look at the distribution and arrangement of electrons. So once we knew how the electrons were arranged around the atom, there was a need to know the arrangement of electrons. So there was a rule to identify and arrange the electrons. Rule number one. Rule number one says that you have to start arranging the electrons from the lower energy shells. That is, we start arranging the electrons from K, next move on to L, then M, and finally we move on to N. So distribution and arrangement of electrons. After Bohr proposed the way the electrons were arranged around the atom, there was a need to know how to arrange these electrons. So the rule number one was to arrange the electron from the lower energy shells. The next rule was to identify how many electrons should be placed in each cell. To know how many electrons need to be placed in each shell, we had to follow the rule 2n squared, where n represented the number of the orbital. So I told you in my previous slide, Bohr named the orbitals as K, L, M, N. He also named them as 1, 2, 3, 4, etc. So now based on the second rule, if we have to follow 2n squared, then the number of electrons in the first shell K will be equal to 2. The first shell is called, the number is called as 1, where that is equal to 2. So you could arrange only 2 electrons in the first shell. The second shell will have, the number of the second shell is 2. The second shell will have only 8 electrons. The third shell will have only 18 electrons, and the fourth shell will have only 32 electrons. So this was the rule proposed to arrange the electrons. So first rule to arrange the electron was to arrange the electron from the lower energy shell going forward to the upper energy shell. The second rule was to follow 2n squared, where n represented the number of the shell. So K shell could have only 2 electrons, L shell could have only 8 electrons, M shell could have only 18 electrons, and N shell, the outermost shell, could have only 32 electrons. Clear? There was the third rule, and the third rule was called as the octet rule. According to the third rule, the outermost orbitals should have only 8 electrons to complete its octet. So according to the third rule, the outermost shell should have only 8 electrons to complete its octet. Now let's take a quick look at these rules once again. So what was the way in which the electrons could be arranged? The first rule, the electron should be arranged according to the lower energy levels. So the electrons had to be arranged from K shell first and then move forward. The second rule was how many electrons could occupy each cell. To identify how many electrons could occupy each cell, we had to follow the rule of 2n squared, where n stood for the number of the shell. Last rule was to follow the octet rule. That is, the outermost shell had to have only 8 electrons. I think we will be able to understand this concept if we could take some examples. Let's see if we could take some examples here. Let me pull out a plain slide. All right. Through my experience, I know that the atomic number of sodium is 11. Through my experience, I know, sorry, let me adjust it. Yes. Through my experience, I know that the atomic number of sodium is 11. Dear students, you need to know the atomic number of most of the elements. So please take a look at it, and you have to be well versed with the atomic number. So how do I know the atomic number? Because through my experience. Yeah, so the atomic number of sodium is 11. So what was the first rule? The first rule was to start arranging the electrons from the lower shell. So if this is the nucleus with the protons, let me start arranging the electrons now. So this is my K shell. So I need to, this is my K. This is my L. This is my M. And this is my yes. Let's get started. So this is my K. This is my L, this is my M, and this is my N. So what was the first rule? The first rule was to start arranging electrons. Start arranging the electrons from the lower energy shells. So I start arranging it from K. What was the rule number 2? The rule number 2 was to identify and arrange the shells, identify and arrange the electrons based on the rule 2n squared. So the first one, 2, the first shell is 1 times 2 will give me 2. So I'm going to arrange 2 shells in the 2 electrons in the first shell. We change the color. Let me arrange 2 electrons in the first shell. So out of 11, because sodium's atomic number is 11, I have already arranged 2 in the first shell. So the difference is, after you subtract, the difference will be, now I have 9. All right. Now I have to arrange the shells in the second level. That is 2n squared. You have 2 into 2 times 2, that is 8. So I can arrange only 8 in the next shell. So I am going to distribute 8. 1, 2, 3, 4, 5, 6, 7, 8. So I've already distributed 8. So I am left with only 1 electron, which I am going to place it in the outermost shell. And what does rule number 3 tell? Rule number 3 states that the electrons, the outermost shell, must have 8 electrons for it to be stable and to complete the octet. But here, let me change the color. But here I have only 1 electron in the outermost orbital. So the sodium is unstable because it has not completed its octet. Clear? Let me go through it once again. So we are going to see how we are going to distribute the electrons. We are going to see how we are going to distribute the electrons based on the rule. The first rule states that the electrons must be arranged from the lower energy shells. So I've started arranging the electrons from K. The second rule states that to identify how many electrons are you going to place in each cell? We have to follow 2n squared. So based on that, I know that always the first shell will have 2 electrons. So my atomic number of sodium was 11. So after distributing 2 electrons, I only had 9. And through this formula, I know that the next energy shell can have 8 electrons. So after placing 8 electrons, I had only 1 electron in the M shell. What does the third rule state? No matter what happens, the outermost energy shell must have 8 electrons to complete the octet. But here, the outermost energy shell in case of sodium is M, but it is having only 1 electron and hence it's not able to complete its octet and sodium is unstable. I hope this is clear. Now let's move on to our next slide. Yeah. So far we have studied Bohr's model of an atom. What he stated that there is an atom. Atom has positive charge in the center in a very small amount and the protons are very heavy. Revolving around the protons are electrons. They are revolving in discrete shells, that is separate shells which have different energy levels. I request you to assume this to be something similar to the solar system. Then once he gave the way the protons, neutrons and electrons were arranged, next we had a look at how the electrons were arranged. There are 3 rules which needs to be followed for the arrangement of electrons. Rule number 1, arrange the electrons from the lower energy shell. The lower energy shell here is K. Rule number 2, how should I arrange the electrons? Follow the formula 2n square to know how many electrons fit into each of the energy shells. Third, the outermost energy shell should have 8 electrons to complete its octet. Complete its octet meaning to complete its octet and to be stable. Next, amongst all these discoveries, it was James Chadwick who passed the alpha particles through a very light metal called as beryllium. When he passed alpha particles through a very light material called as beryllium, he found out that certain particles were emitted from the material called beryllium. These were neither positive nor negative, but he observed that these particles which were coming out from beryllium after bombarding it with alpha particles had mass. So, later it was discovered that the nucleus had protons and neutrons. Protons were positively charged, neutrons had no charge and electrons were negatively charged. I hope you enjoyed the video. See you next time. Thank you.